Hi everybody. It's been kind of a long time before we've spoken here a little bit. Today we're going to begin Chapter 6, and I don't believe Chapter 6 is going to take all of that long period of time to do. We're actually going to cover 6.2, 6.3, and 6.4. And what Chapter 6 is about is the concept of polynomials. Now we'll be defining polynomial in a moment, but Chapter 6 is dealing with that concept, polynomials. We'll be adding, subtracting, multiplying, and dividing with polynomials. That is primarily what the objectives are for Chapter 6. Now we're going to begin in 6-2 of Chapter 6. And 6-2 is an introduction to polynomials. And so what we're going to be doing in 6-2 is defining some specific concepts pertaining to this topic called polynomials. And so we'll kind of want to stay a little bit close to some of the key vocabulary that's going to be delivered out. So we'll begin in this way. We can't define the word polynomial until we define what a polynomial consists of. And a polynomial consists of monomials. So we want to define the word monomial first. Now, I would venture to say that most people in this audience would have an understanding of the prefix word mono, of which is a major part of monomial. Mono means one. Like at Disneyland, we have the monorail. That train is on one rail. A monomial is a single term. It's one term that can be represented in one of three ways. It is a single term that can be represented by either a variable, so any letter of the alphabet, any variable would be considered a monomial, or any constant. Now we know that a constant is a real number, so any non-zero constant would be also classified as a monomial. Or the product, meaning multiply, the product of a number and one or more variables taken to any whole number exponent value. Now we're going to take a look at some examples of some monomials, and as we take a look at them, I'll refresh your mind with, again, how a monomial can be represented by. We said that a monomial could be represented by a plain ordinary variable. So the variable g, or any other letter of the alphabet, could and would be classified as a monomial. So g, x, y, c, t, they're all examples of monomial. A monomial can also be represented by a constant term. A constant. -15 is a constant. It's a real number. It's an integer. It is also a monomial. 5/6 is a constant. It's a rational number. It's a real number. It's also a monomial. Any non-zero constant is an example of a monomial. But the most common looking monomials are expressions that are found by multiplying a number with one or more variables taken to any whole number exponent. 9x, this little algebraic expression right here. It's an expression that represents the product of a number and one or more variables taken to a whole number exponent value. When we read this, we say 9x, but it also means 9x to the first. We don't see the exponent of 1 there, but it's implied to be there. 9x is an example of a monomial. -3x to the second, y to the fourth. Or maybe another way of saying it, -3x squared, y to the fourth. This too is a monomial because it represents the product of a number and one or more variables taken to any whole number exponent value. Monomials are single terms that can either be represented by a plain ordinary variable, a plain ordinary constant, real number, or it can be represented by the product of a number and one or more variables taken to exponent values. Now, one key characteristic that monomials have what's referred to as degree. Not the same type of degree as the temperature outside today, not the same type of degree that we would speak to for the measure of an angle. Monomials have degree. And here's what the degree of a monomial is. I tried to make it just to the point. We find the degree of a monomial by taking the exponents on the variables only and finding their sum, or adding them together. Now let me just read what I wrote. The degree of a monomial is the sum of the exponents on the variables only. On the variables only. Now I have 4 different monomials right down here at the bottom of this whiteboard. And you can see the boxes below each one of the 4. We're going to identify the degree for each one of these monomials. So we're going to start with this one right here. The degree of a monomial is found by taking the exponents on the variables only and adding them up. That's what the word sum means. Add them up. So we take the exponent of 2 that belongs to the base of x, and we take the exponent of 5 which belongs to the base of y, and we add the exponents on the variables only. Exponent of 2, exponent of 5. Add them up, and whatever that sum is, that's our degree. 2 plus 5, 7 would be the degree of that monomial term. Secondly, 2/3, A, B, C. To find the degree, we're going to add the exponents on the variables only. Now you don't see the exponents on each of the variables. So when you don't see them with your eyes, it's implied that the exponent for each and every one of those variable factors up there is 1. So this actually is 2/3 A to the first, B to the first, C to the first. So you have an implied exponent of 1 there, 1 there, 1 there. You add up your 3 ones together, 1 plus 1 plus 1. The degree of the monomial 2/3 ABC is 3. Because each of the exponents in the upper right-hand corner of the variables A, B, and C are implied 1s. And if we add all 3 of the ones together, we get a degree of 3. Thirdly, 15A, B to the 4th, C to the 6th. We can clearly see the exponent of 4 and clearly see the exponent of 6, but we have to make sure that we also acknowledge the exponent on the base of a, which is an implied 1, 1 plus 4 plus 6, 11 would be the degree of that monomial. And then fourthly, the constant term 17. We've already defined that it's a monomial. Its degree, well, its degree can be nothing because we don't have any variables attached to it, and the degree of a monomial is found by adding the exponents on the variables only. If we don't have any variables, then we cannot have a degree for that monomial, and therefore it would be a degree of 0. So that's what we mean about a monomial and the degree of a monomial. Now, let's go to the key vocabulary word in not only 6-2, but chapter 6. Polynomial. Polynomial. Everybody in the room would know that poly means many. A polynomial is many monomials. Many monomials added together or subtracted from one another. Let's give you a definition of a polynomial. A polynomial is an expression. It is not an equation. It's an expression that represents a sum of monomial terms. Doesn't matter how many monomial terms. It's an expression that represents a sum of monomial terms. Now, right below that definition, I have written down 4 different examples of polynomials. All 4 of them are polynomials. 3 of the 4 that are up here are polynomials that have specific names attributed to them. One of them is simply going to be called a polynomial. The other 3 are polynomials as well, but the other 3 that we're going to come to are specifically named polynomials that have specifically new names given to them. Let's start with this first one because it is a polynomial. It has no other name that can be given to it. I'll just read it. -15 x squared y to the 7th plus 2x squared y squared z plus 14x to the 8th minus 15xyz. This is a polynomial expression because it represents a sum of monomial terms. This is a monomial term, this is a second monomial term, a third, and a fourth. Because all 4 of those monomial terms that make up this polynomial fit the guidelines of what monomials are supposed to be. When they're collected together and they form a sum, we call them a polynomial. Now, you definitely see an addition sign there, and you see one there. You see a subtraction sign there, and many polynomials have subtraction signs within them. Because remember, every subtraction statement can be changed into an addition. I can change that subtraction sign to an addition if I make sure that I change this term to its opposite, which it would still remain a -15xyz. So this is an example of a polynomial. Let's go down to the second one. It is a polynomial as well. Let me just read it. 15x squared minus 11xy minus 18y to the 4th. It is just as much a polynomial as the one up above that we already covered. But this polynomial has a special name that's given to it. every polynomial that has exactly 3 terms. Not more than 3, not less than 3, but exactly 3 monomial terms. Number 1, number 2, number 3. It's called a trinomial. By the way, the one up above that we just identified, it is a polynomial. There is no other name given to it. This one, because it had exactly 3 terms, is called a trinomial. Third one, 25x to the 5th, y to the 3rd, minus 9xy to the 6th. This is a polynomial as well. But this polynomial has exactly 2 terms in it. And any polynomial that has exactly 2 terms is called a binomial. I know some of you said it before I did. A binomial, because it has exactly 2 terms. And so its specific name is a binomial. And then the last one, negative 18.5 a squared b cubed c to the 4th. Notice, you don't see any plus signs in it. It only has 1 term. And we've already defined a polynomial that only has 1 term. It's called a monomial. We've already defined it. But I just included it on there again so you could see. So in summary, before I kind of leave this area, if you're looking at a polynomial expression that has more than 3 terms in it, it's called a polynomial. More than 3 terms. If it's a polynomial expression that has exactly 3 terms, it's called a trinomial. If it's a polynomial expression that has exactly 2 terms, it's a binomial. And if it is a polynomial expression that has exactly 1 term, it's called a monomial. They are all polynomials. It just so happens that certain polynomials have a specific name that they go by. Now, I'm going to erase the information that's in the boxes right here, so I won't have to do it in a couple of minutes. I want to erase them right now because these same problems that you see up here, we're going to be using these problems to discuss another key concept about polynomials. Now I'll kind of get myself out of the way so Kristen can just hold the camera right up here. Polynomials have degree as well. We just spoke about the degree of a monomial. We said that the degree of a monomial was taking the exponents on the variables only and adding them up. And whatever that total number was, that was the degree of the monomial. Now let's hit the degree of a polynomial. Here are the key words. Now, you're not going to necessarily understand what is meant when I just read this, but when we go to finding the degree of a polynomial, you'll see what I'm talking about as we discuss it. The degree of a polynomial is the greatest degree of any of the terms that make up the polynomial. The degree of a polynomial is the greatest degree of any term of the polynomial. Greatest degree. Greatest degree of any term that makes up the polynomial. Now we're going to pull away from that chart and we're going to go back to the examples once again that we already looked at up here when we were classifying polynomials. I had polynomial here for this one, I had trinomial for him, I had binomial for him, and I had monomial for him. We're going to start with this guy right here. And we're going to identify the degree of this polynomial expression. The key words for the degree of a polynomial, it's the greatest degree of any term that makes up the polynomial expression. Now let me tell you what I would do to find the degree of a polynomial. Start with the first monomial term that makes up the overall polynomial expression. We'll go one by one. We're going to start off with this first monomial term, and we're going to identify its degree. And I'm going to write that little answer down. And then I'm going to do the same thing for the second term. I'm going to do the same thing for the third. And I'm going to do the same thing for the fourth. First thing that we want to do, start with the first monomial term of this polynomial expression. And we're going to identify its degree. To identify the degree of this first term, we're going to take the exponents on the variables only and add them up. 2 plus 7. I'm going to put a little arrow down right here. I'm just going to write down the number 9. People, the degree of this first term is 9. Let's mosey on down to the second one. And let's identify the degree of this one. This exponent for x is 2. The exponent for y is 2. And the exponent of z is an implied 1. We're going to add the exponents for this. 2 plus 2 plus 1. The degree of that second term is 5. Go to the third, and we'll identify the degree of the third term. Well, there's only one variable that makes up this third term, so whatever its exponent is, that's the degree of that one. And that would be an 8. And then we go to the fourth. There are 3 variables seen there. We don't see the exponents in any of them, so the exponents for each one of them is an implied 1. You have a 1 there, a 1 there, and a 1 there. Add those ones together, the degree of that last term is 3. Now let's go back to the definition for the degree of a polynomial. The degree of a polynomial is the greatest degree of any term of the polynomial. We identified the degree of this first term, it was 9. We identified the degree of this second term, it was 5. We identified the degree of the third term, it was 8. And we identified the degree of the fourth term, and it was 3. We now take the greatest number amongst those 4 that we see, because we want the greatest degree of any of the terms that are up there. And the greatest degree is 9. 9, therefore, is the degree of this polynomial. Now, just pausing for a bit. Before I go to the second one, I want to point out a very common mistake that a student will make, that an instructor could make, that anybody could make. Here is a common mistake that a student will make on an exam. When they are asked to identify the degree of a polynomial, they will remember in their mind that degree of polynomial is greatest degree. And the mistake that a student will make is they'll make a quick survey of this polynomial, and they'll see the greatest number, the greatest exponent value is 8. So they will sometimes make a mistake and instinctively say that the degree of this polynomial is 8 because it is the largest exponent value that they see amongst all of the terms. Well, we just found out that the degree of this polynomial was not 8, but some people will call it 8 because they see 8 as being the largest exponent amongst every one of the exponents up there that they see. No, you don't want to do that. You start with each and every monomial term and you add the exponents first. 9, 5, 8, and 3, and 9 wins. The degree of the polynomial is not 8, it is 9. Let's go to number 2, or the second one. First thing that we want to do to identify the degree of this trinomial is identify the degree of each term, first of all, that makes up that trinomial. So let's start with this first one. There's only one variable. Whatever its exponent is, that's its degree. The middle term. The x has an implied exponent of 1. The y has an implied exponent of 1. We add the 1 and the 1 together. That is a degree of 2. And then we go to the third term. There's only one letter. Its exponent, therefore, is going to be its degree. We got a degree of 2 here. We've got a degree of 2 here. We've got a degree of 4 there. We take the greatest degree. No, do not add all of those up. That's not what it says. Take the greatest degree of any term. That's the greatest degree. 4 would be the degree of that polynomial. This one. Let me just speak to the error first while Kristen is holding that thing right there. Here's a big mistake. People will just look at it and they'll automatically say, I believe the degree is 6. Because they see an exponent of 6 being greater than any other exponent that they see with their eyes. Don't do that. Don't do that. Go to the first monomial term and add the exponents on the variables only. 5 plus 3. Add the exponents on the variables only. 1 plus 6. That degree was 8. That degree was 7. We take the greatest degree. The greatest degree is 8. Done. And I'll go ahead and speak to this one. This is a monomial. So when we identify the degree of this monomial, it doesn't have any more terms to it. It's just a monomial, so we just simply add the exponents on the variables only, just like we did over here. 2 plus 3 is 5, and 5 and 4 is 9, and 9 would be the degree of that monomial. So in summary, when we are finding the degree of a polynomial, you find the degree of each and every term that makes up that polynomial, and after you have found the individual degrees of each of the monomial terms, you then pick the biggest number, and you'll have the degree of that polynomial. Now we're going to summarize a couple of things with 3 exercises right here, because in your homework assignment that's going to accompany the video, part of your assignment is going to give you this direction. For each polynomial, identify each term, the coefficient of each of those terms, the degree of each term, and the degree of the polynomial. So let me just summarize before we enter into number 1. Here are the 4 items that they're going to be asking you to do. They're going to ask you to identify each term that makes up the polynomial. Secondly, they're going to ask you to identify the coefficient for each and every one of those terms. Third, they're going to ask you to identify the degree of each one of the monomial terms. And then finally, to identify the degree of the polynomial. Now, I don't have very much room here for these three, so I'm going to do it very carefully and try to be specific enough about what they're wanting you to do. Number one, here's our polynomial. 3x squared minus 7x to the fourth minus x plus 6. Item number one that they're wanting, they want you to identify each term. So I'll try to do it just right here in the limited space that I've got. Term number one, 3x squared. Term number two, negative 7x to the fourth. Term number three, notice how I say it and notice how I write it. There's no such thing called negative x. There's a negative 1x, so I'll write that. And then fourthly, the constant term positive 6. Those are the four individual terms that make up that polynomial expression. That was the first thing that they wanted us to do, identify each term. I did. Secondly, identify their coefficients. Now this time around, I'm not going to write down the coefficients, I'm just going to speak them. The coefficient of the first term, 3x squared, positive 3. The coefficient of the second term, negative 7. The coefficient of the third term, negative 1. The coefficient of the fourth term, positive 6. So those are the coefficients. I felt I could just do that because we should already be well versed in coefficients. Now thirdly, they want us to identify the degree of each one of these terms. Let's go to this term right here. The degree of this term, 2. I'll just kind of draw an arrow. 2. The degree of this second term, 4, because there's nothing to add 4 with. There's only one letter, 4. The degree of this third term, well, the exponent in the upper right-hand corner of that variable x is an implied 1, so its degree is 1. And the fourth term, there are no variables, so its degree is 0. So thirdly, they've asked you and me to identify the degree of each of the terms that make up that polynomial. This first term, a degree of 2. This second term, a degree of 4. This third term, a degree of 1 because its exponent is 1. And fourthly, its degree is 0 because it doesn't have any letters. Finally, it's asking for the degree of the polynomial. The degree of the polynomial is the greatest degree of any of the terms of the polynomial. Well, this first term had a degree of 2. This second had a degree of 4. This third had a degree of 1. This fourth had a degree of 0. The greatest degree is 4. 4 would be the degree of that polynomial. Now let's get through 2 and 3, and then I'll kind of ask Kristen how much time that I've got. If I've got to close it off, I'll close it off. Number 2, polynomial. 12x to the fourth y minus 5x to the third y to the seventh minus x to the second plus 4. Polynomial. Question number 1. They want us to identify each term. Term number 1, 12, x to the 4th y. That's term number 1. Term number 2, negative 5, x to the 3rd, y to the 7th. Term number 3, a negative 1, x squared. And term number 4, positive 4. Then they're asking for the coefficient. I'll speak it. We should already know the coefficients. Of number 1, the coefficient is positive 12. Number 2, the coefficient is negative 5. Number 3, the coefficient is negative 1. And number 4, the coefficient is 4. Now, thirdly, we're going to identify the degree of each of the terms. So let's identify the degree of term number 1. The degree of term number 1, take the exponents on the variables only and add them up. 4 there, and implied 1 there. 4 plus 1, the degree of that first term is 5. Let's go to the degree of the second term. 3 plus 7, 10. The degree of the third term, there's only one letter. Therefore, whatever its exponent is, that's its degree, 2. This one, no letters, degree of 0. Degree now of the polynomial. Greatest degree. There are 4 individual degrees here. We want the greatest, 10. That would be the degree of that polynomial. And thirdly, let's do the third one. 3x to the 6th plus 4x to the 4th y to the 4th minus x cubed y plus 4x squared minus y. Term number 1, 3x to the 6th. Term number 2, a positive 4 x to the 4th, y to the 4th. Term number 3, I'm going to identify the coefficient when I write it. Negative 1 x cubed y. That's term number 3. Term number 4, a positive 4x squared. Term number 5, a negative 5. Coefficients, I'll just speak them. Positive 3, positive 4, negative 1, positive 4, negative 5. Now to the degree of each of the 5 terms. Degree of this first term. People, there's only one letter, so whatever its exponent is, that's its degree, 6. Second term. There's more than one variable. So if there's more than one, you're going to have to add the exponents together first of just those variables. 4 plus 4, that degree is 8. This one, it has 2 variables. We're going to have to add the exponents together. 3 plus an implied 1, that degree is 4. This one, only one variable, therefore its degree is 2. This one, there aren't any letters, it's a degree of 0. And then finally, the degree of the polynomial is the greatest degree. Well, here's our 5 individual degrees. 6, 8, 4, 2, 0. The degree of number 3 is 8. It's the biggest. 8 is the degree of that polynomial. Okay? Do we have time?
We have 40 minutes now.
Huh?
We're at 40 minutes.
That's cool. Call it right now, folks, and we'll regroup. Thank you. See you in a moment. Bye.